In this video, we're going to review measures of center. In particular, the mean, median, and mode. Mean is the average of a set of numbers. We calculate the mean by adding up all of the numbers and then dividing by the total amount of numbers. So if we had three numbers, A, B, and C, the average of them would be A plus B plus C over 3, because there are three numbers. The median is the middle number in a set of numbers. So let's say we had A, B, C, D, and E. And let's say that A is less than B, is less than C, is less than D, and is less than E. In other words, they're in order from smallest to largest. So the median is going to be the middle number. So we can count 1, 2, 3 from the bottom and 1, 2, 3 from the top, and we'd see that the median is going to be C. If we had an even number of numbers, so let's say we just had A, B, C, and D, and these were also in order, then we would have 1, 2 from the bottom and 1, 2 from the top. So the median would actually be the average of those two middle numbers. So it would be B plus C over 2. Finally, we have the mode. The mode is the number that shows up the most frequently in a set of numbers. So if we had A, B, and C, then the mode would be A, because A shows up twice, whereas B and C only show up once each. For our first practice problem, we're going to find the mean, median, and mode for the following set of numbers. Let's start by counting the total number of numbers in the set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. Now let's add up all the numbers. You can do that on a calculator, or if you're good at mental math, you can do it in your head. Anyway, when we add up the value of those 12 numbers, we get 56. And that's the sum of the numbers. So the mean is going to be 56 over 12, which is equal to 4 2/3. For the median and the mode, it will be helpful to put these numbers in order from smallest to largest. So we have 1, 2, 2, and 2. So I'll put those in order here. We have 2 3s and a 4. Then we have a 5, a 7, 2 8s, and an 11. We have 12 numbers, so we should count from the bottom 6 and from the top 6. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So the median is going to be 3 plus 4 over 2, or 3.5. Last we have the mode. And the mode is going to be 2, because 2 appears 3 times in the number set, and no other number appears more than 2 times. So the mode is 2. The next problem is a classic ACT question on measures of center. John took 4 math tests this semester and has an average score on those exams of 77. He has 1 test remaining. John will earn a B in the course if his test average for all 5 exams is at least an 80. Which of the following inequalities shows what John needs to score in order to get a B in the course? So he's taken 4 exams and his average so far is a 77. So we're going to let 77 times 4 be the scores on the first 4 exams. We know that he has 1 more test to take, so we're going to add that with an X. When we get the average of all 5 of those exams, we divide the total score over the number of tests, 5. That should be greater than or equal to 80 for him to get a B. This inequality represents that, but this doesn't show up in the answers. So let's do some algebraic manipulation to see what we can find. So if I multiply both sides by 5, I can cancel the 5s on the left, and then we're left with 80 times 5 on the right. That's going to leave us with 77 times 4 plus x is greater than or equal to 80 times 5. Now we're going to subtract 77 times 4 from both sides. That will leave us with x is greater than or equal to 80 times 5 minus 77 times 4. And we can see that this is in fact answer choice B. Our last problem is another classic ACT problem on measures of center. Set A and set B each consist of 9 numbers. Within each set, no two numbers are the same. Both number sets are ordered from smallest to largest and have the same median and the same mean. We replace the lowest value from set A with an even smaller number, and the 5th number in set B with a number that is exactly 1 larger. Which of the following must be true? So scanning the answers, it looks like everything is discussing the median and the mean. So let's figure out what changed in set A and what changed in set B. So for set A, we did change one of the numbers by lowering it. So that means the mean is going to be lower in set A. However, we did only replace the lowest value from set A, so that shouldn't affect the median. So the same median is going to exist after we change the number as was there before we changed the number. For set B, we replaced the 5th number. The 5th number, when you have 9 numbers, is the median number. So we changed the 5th number and made it exactly 1 larger. So that means the median has to be greater. Again, since we increased one of the numbers, that also means that the mean has to be greater as well. So let's look at the answers and see what matches up. It looks like E, the mean for set A becomes smaller, and the median for set B becomes larger. It's correct. That choice doesn't mention anything about the mean for set B, but that's okay, because nothing in the statement is wrong.